In today's video, I am going to explain a little bit more of the methodology as to why I am using the type of rig that I am using to flex test risers. And I'm also going to show you some improvements that I've made and do our very first flex test on this Gillo GT. For those of you that are new here, my name is Kaminski. I'm a two-time Olympic silver medalist in the sport of archery, and we're going to make this channel a great resource to all types of archery. So if you haven't yet, hit that subscription button and the notification bell. That way you're notified every time a new video is uploaded. I'd appreciate it. So if you haven't seen my previous video explaining a bit more in depth as to why I am doing this and why I'm flex testing risers, I'll put a link in the description below, plus I'll put a card at the top up there. So that way you can check out a bit more of the reason why I'm doing this and to see the discovery phase of actually flex testing risers to see how excited I was. And I have definitely taken your comments and suggestions and feedback and done as best as I can with what I have. Now, I have made a few changes. I've made a change here to the actual measurement device as far as what I am measuring off of. I've also changed the laser configurations up a little bit and the types of lasers and a few of the other details as well. A couple of things that I did take into consideration for sure is using a more clean looking, easily viewable setup here. And you can see now I have a target that has 3 separated marks for the 3 different lasers. So that way you have your top pocket separate from your arrow and your bottom pocket separate from the top pocket as well. So it's just going to make things a bit more cleaner. I use dots now because the crosshairs just kind of confuse things and it's not any more accurate at all. I think this is just a little bit cleaner and a little bit easier to see. Now, previous to this, I had this stabilizer mount or gauge or whatever you want to call it in the actual stabilizer bushing. And as you saw in the previous video, I discovered for myself that the riser actually flexes between the actual arrow and the stabilizer, which I was surprised about because, they're relatively close together, so they shouldn't flex all that much as far as I was concerned. So, it raises concerns of, okay, where is the riser flexing? It's probably flexing throughout the entire riser, obviously, and it's not just near the pockets. I wanted to make sure that I could see the top and bottom limb flexing, the top and bottom pockets rather, flexing different from where the arrow is as a good center reference. Now I've switched my laser holders basically to be in the center of the back side of the riser because not every riser is the same width. So as the width changes, so does too this laser location, and now it is pointing towards the right. And if the pocket were to be flexing, the laser would move in an arc and it would actually show an out of plane flex that really wasn't happening because of that offset angle. Now, right now what I have done is I have put the mount rather, in the back side of the riser, so that way I can be in a really good consistent location. From riser to riser, you'll see, on this win and win, there's a nice spot here between the limb bolt and the actual dovetail mount. Same will be on formula bows. And, it'll just be a lot cleaner because then I'm not mounting to this surface, which is much wider on this bow compared to this surface, and that would throw results off and be rather inconsistent. So I wanted it to be as clean and repeatable and as little bit of influence as possible. Right now, obviously, the Gillo GT is an offset riser. It's asymmetrical. It's longer on the bottom than the top. And so what that's going to do is when the bottom pocket is moving, it's going to show that it's moving more because the pocket is longer. Also, the distance to the target is longer. Same from the top. The top is shorter than the bottom. So what I will do in my results, I'll post the raw results, but then I'll post corrected results for the actual difference in distance change and, base it off of the pocket itself. For instance, it's a 35.5-inch measurement from the top target to the top laser and 38 inches from the bottom target to the bottom laser. I could orient this and change this to take that into consideration and have the bottom much further down and all that stuff, but then I'd have to change it for each individual riser. It's a lot of extra work, and this is a much simpler way. I can just figure in the factor to change that percentage to show, okay, the bottom should be moving a little bit more than the top based on the length is, it's magnified on the bottom. So all that stuff can be taken into consideration and will, again, make much cleaner results. A few people have mentioned, oh, well, you have this peg here and it's up in the pivot point and not down where the pressure point is. Yes, that is very true, but this is not my riser, and the grip does not fit this peg very nice. I don't want to crack the grip. This can be very repeatable, and so I can just take every grip off of every bow and do it like this on the peg. So that way apples to apples can be compared. And because I may be putting pressure different on the bow than you do versus a high risk, low risk, and all those changes, it's really impossible for me to basically say, okay, well, here is measurement for your grip, my grip, their grip, someone else's grip. It's a lot of work, not possible. So we're just gonna do something that's repeatable, so that way you can correlate and do your own work with my data to compare this riser to another riser. That's the whole point of this, is to see how are different risers flexing. Are different manufacturers doing a better or worse job? Are carbon fiber risers better than aluminum risers? Are risers consistent to other risers? It's really going to be interesting, and this is definitely still the discovery phase. This is a great visual representation to be able to see any sort of movement, and it really just is going to be, it's fun. It's going to be exciting for me at least. Now, yes, I am using a draw board with a single rope attachment, much like a compound does. But I can tell you from experience, and I will prove it to you in a video, potentially this video, that whatever I'm doing back here on the string, whether it be trying to torque it or anything like that, it won't change the relationship between the laser and the string alignment, or the lasers and the tiller alignment, or the actual, anything to do with the bow. It's all in the bow hand. The bow hand affects a ton, the string hand doesn't. I've done the testing on my own, and you'll be surprised to see that is most likely the case, at least if it holds true to the testing that I've done in the past. I have also controlled a lot more variables within the system. I forgot about a couple things, kind of a small airhead type move, unfortunately, because I was so excited, and I just didn't zero it out for the actual test that I did in the previous video. So now I have made slight adjustments. I'm doing it at a slightly higher draw weight. I'll have to check that here to make sure. And the reason I'm doing that is because, well, I forgot that the Gillo pockets move so much, and I forgot I had them set very, very weak because of my test videos that I've done in the past with this Gillo GT. So I had to screw it back in to be considerate of other risers. And so I've got about, a pound or so heavier. I'll remeasure that to be sure and make sure that is consistent. The peak draw weight from bow to bow. The tiller is zeroed. The limbs are perfectly aligned, at least according to my standards. And, I have really made sure that I have really controlled this as much as possible. I've set the brace height exactly where I like it at 22.5 centimeters, so that also will be controlled. And I'll do some more other tests in the future of flipping the top limb to the bottom limb, making sure the limbs are still aligned, reset the zero of the tiller to see if that changes at all the deviation of the lasers. Just because more data is better to see how things are going. For all about the same consistent way, the way I'll test that ATF, my TFT, my whatever, the Meta DX, all of those risers, and the Hoyts that I've got laying around and have sitting back here behind the camera, that I will be testing. They're all going to be with this same limb, with the exception of formulas, and those will have a dedicated set of limbs that I will always use to measure formula bows. So this limb, this top limb from Win and Win, this NS, and this bottom NS, this exact set of limbs will be used on every single riser that I test that is ILF. So that way, even if the tiller is a little biased, like it's at zero now at brace height, but at full draw, maybe the top limb's stronger than the bottom or vice versa. I don't know, I haven't tried it. We will be able to compare this riser to another riser because I won't be changing the limbs at all, even top and bottom. Gonna stay the same, that way it's consistent. Same thing with the laser positioning. They will all be in plane, so it's consistent. I will just work on making sure that they're as close as possible together and it's as controlled as possible together. A lot of people have really good suggestions using dial indicators and jigs and fixturing and all these things. Yeah, that would be great if I had an unlimited budget, but for a lot of those type of things, I just don't have the budget around to do that type of thing. This is a great visual representation. Yes, when this laser moves 1 millimeter, this pocket is not moving 1 millimeter. Due to the parallax effect, the magnified length effect of the actual movement indicator, it is moving much, much less. That isn't the point. The point is, try to compare this riser versus that riser. If this laser is moving 2 millimeters and that one only moves 1 millimeter, you know that bow moves less than this bow. as long as the length is the same, of course. And all of that will be noted in all of my data, so that way there is a corrected corrected reference point for everything to be referenced off of. I'm excited. I have changed this mount up here to basically be in line with the arrow, using the actual flex plate that I machined or had machined to do these tests on. And that is now the reference point for the arrow, as you can see. And it actually doesn't move as I draw back. Much cleaner results. This is just an extra indicator of, okay, is it working the way it should? And it shows that it is. So I'm happy about that. I have got this dot zeroed out here on this top pocket. It's maybe a skosh high. I'll fix that. And the bottom pocket's maybe a teeny tiny bit to the left. I will also fix that. I have batteries now for my calipers. I'm happy about that, and thank you for the person who had the tip of taking the battery out so it doesn't have parasitic drain and it keeps the batteries longer. Good tip, thank you. I appreciate all the feedback. I appreciate the suggestions. I appreciate the concerns, the questions, the everything, because, you know, it is challenging. You know, it's challenging to explain. I forget things to explain to you as to why I believe this is important, and I thoroughly thank everyone who has commented and thoroughly thank everybody who has had suggestions. I do also want to take some time really quick to thank everybody who's been supporting my channel, because it's been right about a year since I started this channel up officially to produce content for YouTube specifically, and it's been exciting. You know, it's been great, and I genuinely appreciate everybody's support and feedback and love and kindness and even criticism, because I too can get better, and I will continue to get better as this channel grows. So thanks to everyone on Patreon, thanks to my YouTube channel members, thanks to the people who have donated directly to me through PayPal, bought any of the books that either I or my wife and I have wrote together, any of that stuff. Any way that anybody has supported me, even if you've shared this video or shared other videos, that still helps me and my channel, and it allows me to produce a lot more content. It allows me to do this. I bought these lasers and then devised this plan because I wanted to, and I wanted to share it more with you guys, and I wanted to educate the archery consumer so they can see what's actually going on and put to rest some of these manufacturers' claims about certain stuff. And so it's going to be really fun to build this database to see how things go, because it's neat and it's exciting. So anyway, thank you to those who have been supporting me. I genuinely appreciate it. So before we do any sort of flex testing officially, I want to get a new draw weight set up. So I'm going to unplug these because, you know, I don't want to spoil the fun. We'll leave the arrow one on so you can see how that one doesn't move. But I do need to get a new draw weight indication of what we will be working with. And hopefully everything that I have explained so far in this video is going to really make you understand a little bit better as to the methodology of what I'm doing and why I'm doing it and why I'm using a draw board instead of fingers. I actually have fingers that I've made in the cabinet, and we'll be able to test how to split finger versus 3-under versus string walking affect the way your bow flexes. It'll be cool to see, but being able to do it repeatedly like this, drawn from the same place, from the same knocking point reference, which I will measure and make sure that I use as a same reference point every single time, you know, you'll be able to see it, and you'll be able to experience what I'm experiencing here, and hopefully you'll see that the data is as clean and consistent and as controlled as I could possibly make it. All right, so I am now testing it at 47.07 pounds. So I'm gonna go for 47 pounds here every single time I test different risers. So 47. So again, I'm still going to draw the bow back just underneath the bottom knock with the arrow clipped in the knock groove, so I can have the draw length measurement. Once I get it back to full draw, I'll take the arrow out, and it looks like I bumped that apparently, so unfortunately I have now to reset it. The bow is leveled here with this 3rd axis level from Kaminski, and my level is here. My bubble's level, and the bubble on the bow is level, so the plate is level to the bow, the measuring plate that is. The laser is in the center of the crosshairs. It looks a teeny tiny bit low on this. I have the exposure turned down on the camera as much as possible. It's really difficult to get the exposure right so I can see the lasers really easily on the piece of paper. I mean on the camera here. It'll show itself up still. You'll still see it moving. You just won't see exactly how much. Top's good to go as well. So I've got all dots on the origin. They're all as small as I can make them. And I'm now going to draw back this Gillo GT. Just to be sure, I have the bow grip here supported lengthwise in the same place that the draw board is drawing it from. And as I go like this and go through the testing, I will actually grab the bow and torque it for you and kind of move it. And you'll see it's not very sensitive on the actual lasers. They're not moving a whole lot, showing that the riser isn't flexing a whole lot. So that way it's going to really kind of take out any sort of fear that people have as to an inconsistent pressure on the grip. Doing it by machine like this without a weird fixture to try to simulate bow hand pressure is going to make it much easier to compare apples to apples, different bows to different bows, without the effect of having to deal with higher or lower grips and different shapes. Alright, so I'm back at my draw length. I'm going to pop this arrow out. And you'll see, it definitely flexes. And they all flex. Again, not to be worried. All risers do flex. Not a big deal. So I'm going to mark it now. This is a .07 pencil here. I'm going to use a different kind of marker that I can find where I can just tap it really quick where the dot is. The only thing that I'm worried about is bleed, so it makes a big dot. I can make a much smaller dot with this pencil. The arrow didn't move, so I'm not going to mark that. Alright, so I don't know if you can see those, but there's the two marks on the piece of paper. And there's the laser dot. So you can tell that the dot that I drew up top is in the center of the dot. And the bottom is so close. I'm going to make a slight adjustment. You can see the arrow still in the same spot. There. All right, so preliminary, off the hop here, looking at it. Top pocket is deviated just less than 2 millimeters and the bottom pocket is deviated just over 2 millimeters. They have both slightly shifted to the right. The top one is shifted more to the right than the bottom. And I'll get some top and bottom measurements here just to make sure. I'll just do it in centimeters, 90 centimeters, because this is millimeter paper. And that'll be a measurement in centimeters. And to the bottom, 96. So that way I'll be able to do a corrected distance on that one. So now that it's at full draw, you can see it on the paper, or on the camera down here. I'll grab the bow grip, I'll torque it a little bit. And you can see the lasers deviate a little bit, but not a whole lot. They do move, but I'm really twisting this riser, and a lot more so at least than this peg is doing due to flex of the frame. So it's really a very minor amount that it is moving. So now I am going to let down the bow, and I'm going to show you why I am using this target. As you saw it rock back, if I were to just put them on the wall and I were to have the bow moving like that, the lasers would be moving independently different all over the place. The only way that I would have to control that or be able to control that is if I had the lasers leveled and the bow leveled. But because as the bow gets drawn back, it's moving and changing, I just can't control that factor, and that's why I'm using the target mounted to the bow. Clarifies and cleans up a whole lot. If you know of anything out there that is like a laser tracking computerized system, much like cars are aligned with laser pointers to targets, that I could mount on this, that's not like, $100,000. I would love to be able to have that, because then I could have real easily measurable stuff and I don't have to go through so many steps. And I'll let the bow down and draw it back again, and you'll see the laser is going to be in the same spot. It draws it back consistently. It doesn't move differently. My marks may be a tiny little bit off, but it's very, very minuscule. My lasers here are absolutely focusable. I can focus them. and I've got them as small as they possibly can go, and my pencil mark is smaller than the dot is to my eye, so it's as accurate as I can be, and I'm going to do this the same way for every single bow I test, so that way we can really compare how things are going from different manufacturers. So I'm going to let it down, and I'll show you. The lasers go back to their origins just fine, no issues. Draw it back again. My drawboard's loosening up on me. Let's see, that's probably too far. Yeah, I drew it back way too far. That's why the lasers move more. All right, same draw length, and you can see top laser to the dot, bottom laser to the dot. So it's the same place. They don't change. They don't change at all. And I've done it a million times. This bow's actually been strung for a while now. So as far as fatigue goes, it doesn't have it. Trust me, you can draw the bow back 100 times. It's not going to fatigue anymore. You know, I can tell you from experience, it's very difficult to set up, and nor is it really very applicable to this test that I want to run. Going from unstrung to strung, the riser flexes a lot more than it does right here, which is actually interesting to see. But because we align our limbs at brace height and not when the bow is unstrung, I figured that's not very, applicable or important. Nor do the bows completely unload to zero, so you're not going to see tons and tons of movement. The bow will see a lot of movement because of the dynamic forces applied to it when you let go of the bow, or let go of the string rather. So it does change a whole lot. This is, again, just very controllable. I'm going to let this bow down and see if I can get it drawn back by hand and induce some torque on the grip and on the string while keeping it inside the camera viewfinder here so you can actually see what's going on. So this is going to be challenging with all the wires here. All right, you'll see that the lasers are still right there. I'm going to draw it back and try to keep it in camera view. And you'll see, I mean, it moves. They go to zero at brace height, pull it back, and they move. Like, it's pretty wild. So now I'll pull it back, and I'll grab the bow and torque it. I'm torquing it far to the left, so you can see the dots do move slightly to the right. And now I'll torque it to the right, and you'll see the dots move to the left. Pressure in the throat. Pressure on the heel, throat, heel. I don't see it move a whole lot when I induce different pressures on the grip. And now string torque. Torquing the string like this does nothing because it just rotates in your hand. But here's one above, two below. Here's three below. And now I'll go to a super deep crawl. I don't know if that changes a whole lot. It looks like the bottom pocket flexes more with that deep crawl, as to be expected. So I think just doing that in itself and showing you that this does not really have any effect on it. It looks the same. Even the grip pressure, I was surprised that it didn't change more. The torque, yes, it changes, but again, all being drawn on that same peg, all on the same machine, all without a grip, and I think they should all be relatively consistent. You know, the center, it's centered on where it's being drawn to, that would affect it. So I'm controlling as much as I possibly can to make this as consistent as possible. Again, you can see here from this angle, all the lasers are in plane left to right. So due to, trigonometry, basically, it's not going to really affect the top and bottom differently. The length being different because the distance from the target is slightly off will change it, but that's why I will correct the actual results. We're going to rate this bow the very first bow on this channel and see how much it is flexing in raw data on the actual chart when I use a caliper to measure, and then I will use my calculator to correct the actual results. Okay, so I've got the camera rigged up here so you can see overhead and I can still talk to you here. And I'll go to the 100th probably. As you can see, I can zero it out, but it's still just, the resolution's not the greatest. And it's a 27-inch riser, and I don't know the date. The arrow deviation was 0 as expected. And let's see here. I'll take the actual movement. Okay, so before we go any further, just so you know, I actually was totally wrong. This is 2 millimeter square, not 1 millimeter square. So if I measure the actual square, you'll see I'm getting really close. 2 millimeters. Yeah, 1.98 millimeters. I'm really, really close. So I'm going to give 3 measurements and see if they're consistent and take the average of the 3, because I might be slightly off. So on the x-axis, getting about 0.92 millimeters, 0.9, 0.96, 3.3 in the Y, 3.2, 3.15, 3.11. So again, I'm not going to do this every single time in every video. I just want to show you the very first one, how I'm going to do this, and because I'm doing 3 measurements to try to make it as consistent as possible. 4.60, 4.56, 4.53. So that is in the y-axis. 0.36, 0.49, 0.38. So I will take a calculator really quick. Average of the X results and divide it by 3. That is 0.92 and a third. So we'll just call it 0.92 is the average in the y-axis. So that's 3.19 and a third. So I'm going to keep this to the tenths. So I'm going to round up or down in those. Or I'm going to keep this to the hundredths rather and round up or down in the thousandths. This is the X and the bottom here, 0.41, and in the Y, and that is 4.56 in the Y on the bottom. So those are the averages. Now I'm going to take into account the difference in the deviation from the top laser to the target versus the bottom. So 90 divided by 96, that is a 0.9375 ratio. So there's a slight difference here. So that's a 0.9375. So what I should do with this number is I should multiply this number by the bottom pocket deviation to bring that back down to the actual amount, that is applicable to the top 1-to-1 without the length difference. So if I take that number and I multiply it by, we'll do the x-axis first, 0.41, I get a 0.384375. So the corrected bottom pocket X movement is 0.38 is the X movement. The Y on the bottom, 0.9375 times 4.56, and that gives me 4.275. So the Y on the bottom pocket deviated 4.28 millimeters in the y-axis. Now the top pocket in the x-axis deviated 0.92, and the y was 3.19. So even with the corrected distance from there to the target versus the top to the target, the bottom pocket moved a considerable amount more. It moved, at least 25% more. If I did the actual math, in the x-axis, the top divided by the bottom. So the bottom pocket in the x-axis only deviated 41% of what the top pocket did. That's a huge lower amount of out of plane flex, which I'm glad to see. I would expect the bottom pocket to move much less out of plane because the center of the riser is centered from the grip down, whereas the top it's offset due to the sight window, and it's going to cause the bow to essentially kind of want it folding in on itself and turn into a taco or start to twist. And, you know, you just don't want that to happen. And if companies are doing their job and doing their engineering properly, they can help control how much out of plane flex that is. Top pocket, with the corrected numbers, deviated 75% of what the bottom pocket deviated. So it definitely moves a whole lot more as far as the flex towards the archer on the bottom pocket. But as you can see, from the grip down is a much longer measurement from the grip up. You know, it's just a lot longer on the bottom here. It's a lot longer bow on that bottom portion. From where the bow contact point is to the laser, it's almost 30 centimeters. And on the top, it's only 28 centimeters. So there's a 2 centimeter difference, you know, almost a 10% difference in the bottom to top length on this bow from where the pressure point is of the actual pin that I'm using. So the bottom is definitely going to move potentially more, you know, and although it does move a considerable amount more than the percentage difference in length is there. So they definitely have the bottom area of the riser a bit weaker than the top. Now, some of these companies may be doing that type of design on purpose to get a certain type of feel or reaction or whatever. I don't know, and you don't know. The company only knows. And that's why I'm doing this type of stuff, to try to show that, hey, what's going on here? What's going on with our bows? Are they moving? And yes, they're clearly moving. I'm proving it. Although, due to parallax, they're moving up way less than what I'm measuring with these lasers. Now, it really is very minuscule. And now, you know, you might say, oh, well, that's pretty small. Well, I can tell you for a fact, if you put weights on the bottom limb pocket and not the top limb pocket, it's going to change where you need your knocking point to be. So if that is happening, that is telling me 100% that how much the riser is flexing and where it is flexing is going to affect the way it tunes, it's going to affect the way it feels, it's going to affect the way it shoots. And I think it's going to lend itself to less consistency if it's flexing unevenly for the archer. So I think this is really exciting stuff. I'm personally excited about it. I like to know more about my equipment, and I'm only doing it so you at home can understand more about your equipment as well. Yes, it's moving very small, but as you move that small change down range, it makes a massive difference. I did the math once. This was in high school, so hopefully it's pretty correct. I measured, okay, if the knock stayed perfectly still in space and never moved left, right, up, down, forward to back, never moved, but the only margin for error was the point on the arrow. At 70 meters to hit the entire 122 centimeter face, I think I had somewhere in the neighborhood of 1/4 of an inch range for error, which is about 5 millimeters. 5 millimeters to move to hit the entire bail at 70 meters. That's a tiny margin for error. So if those pockets are moving, it's gonna affect where your arrow lands. Absolutely. Yes, it's gonna flex consistently, but there may be consistency issues depending on the mistake you made. Again, if it's moving it up and you make an up mistake, maybe your arrow goes further up than it does down when you make a down mistake, or vice versa. Hard to say. Almost impossible without, you know, changing risers and playing with them. But to hit the 10 ring consistently at 70 meters, the margin for error is something like the fine ball on a ballpoint pen. That's the margin for error to hit the 10 ring time after time at 70 meters. So does it matter? To me, it does. And I think it should to you as well. And that's why I'm excited to make this content to show you more about it. Again, this is about 1 year anniversary-ish that I've been running this channel, and I can't thank anybody enough to, you know, who has supported this channel and encouraged me to continue moving forward. Thanks for all the views, and thanks for sharing these videos. I genuinely appreciate it. And if you're interested in supporting this channel at all, please check out links in the description below. There's Patreon, there are memberships to this channel, there is a P.O. box you can send things to. There are many different ways to support this channel, and you can check them all out in the links in the description below. Again, I can't thank anybody enough, and I genuinely appreciate it, and appreciate you as well. Hey, thanks for watching. If you like this video, consider hitting the subscription button and the notification bell, as well as the like button. I would appreciate it. Also, please consider supporting my channel. If you head to my website, jakekaminski.com, there'll be info and links on Patreon, apparel, books, and equipment sales, PayPal donate button, a P.O. box to send things to, and above all else, please share this video because there's no better advertising than word of mouth.